Hi everybody. Okay, in this video we're going to look at what are called addition and subtraction formulas for trigonometry. And so these are your formulas. Now I don't usually require that you have to memorize these. I usually have them on the quiz or the test for you. You just have to know how to use them, okay? So we have sine of a plus b, sine of a minus b, cosine of a plus or minus b, and then tangent of a plus or minus b. So your addition and subtraction formulas help to extend your unit circle. So we are going to be revisiting the unit circle with this. So the idea is you can find sine, cosine, or tangent of a sum or difference of angles. And so usually what we want to do is make A and B an angle on the unit circle. And the angle can be in degrees or the angle can be in radians. So that we can actually, find the trig value of the sum or difference of the two angles. Now, let's look at an example, and I think it'll make a lot more sense. Okay, so we want to use addition or subtraction formulas to find the exact value of the expression. I do realize you could just key this in your calculator, but you'd have to round your answer, and we want to be able to find an exact answer. Okay, so we're going to start with angles that are in degrees. Let's say we want to find cosine of 75 degrees. Well, the idea is think about two angles on your unit circle that either add, if you add them, it equals 75, or if you subtract them, it equals 75. So, I don't know, what jumps out at me is 30 degrees plus 45 degrees. So, we can rewrite this as cosine of 30 degrees plus 45 degrees. So this is like your A and B. Okay, so then you just go to your formulas and you find the formula that you're going to use. We're going to use this one, cosine of A plus B. And we're just going to plug in 30 for A and 45 for B. Okay, so we're going to end up with, and I'm just going to work this down actually. Okay, so this is equal to cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. And again, you're just replacing A and B in the formula. Okay, this is where your unit circle is going to come in. Now we're going to find cosine of 30 degrees using your unit circle. Well, remember 30 degrees is equal to pi over 6 radians, and cosine of pi over 6 is square root of 3 over 2. Okay, times cosine of 45 degrees, that's 45 degrees is pi over 4 radians. Cosine of pi over 4 is square root of 2 over 2 minus sine of 30, which would be the same as sine of pi over 6, is 1/2 times sine of 45, which is square root of 2 over 2. So again, these are just coming straight from the unit circle. And then we're just going to simplify. We're going to multiply our fractions. So we're multiplying straight across. We get square root of 6 over 4 minus, multiply straight across, and we get square root of 2 over 4. And then we're just subtracting our fractions. We already have a common denominator, so we'll just subtract our numerator and put it over the common denominator. And we'll stop there. So the exact value of cosine of 75 degrees is square root of 6 minus the square root of 2, all divided by 4. Okay, let's look at our next example. We have tangent of 195 degrees. So the idea is, can you find two angles in degrees on your unit circle that either add or subtract to equal 195? again, there's more than one possibility, so you may come up with two different angles than somebody else. But what kind of jumps out at me is 150 plus 45. Okay, so essentially this is tangent of A plus tangent of B. So let's go back to our formulas. We're going to be using this formula, tangent of A plus B, since we're adding 150 and 45. And then we're just going to plug into that formula where 150 is A and 45 is B. Okay, so we're going to get tangent of 150 degrees plus tangent of 45 degrees divided by 1 minus tangent of 150 degrees times tangent of 45 degrees. Okay. All right, so again, that's just plugging straight into the formula. So then you go to your unit circle and you find these values. So tangent at 150 degrees is negative square root of 3 over 3. And tangent of 45 degrees is 1. Okay, divided by 1 minus tangent of 150, again, is negative square root of 3 over 3 times tangent of 45, which is 1. Okay, so this becomes, and I'm just going to switch the terms in my numerator and make that 1 minus square root of 3 over 3. I don't know, it just looks better that way. Over, and then the denominator, because we're subtracting a negative, is going to become adding a positive. Okay, now this one takes a little simplifying. First of all, in the numerator, we're subtracting fractions, so we need a common denominator. So we'll make this 3 over 3. And then we'll do the same thing in the denominator. Okay, so then we're going to add our numerator and put it over our common denominator. Okay, now because we're dividing fractions, we're going to multiply by the reciprocal. So this will become 3 minus the square root of 3 over 3 times 3 over 3 plus square root of 3. Okay, 3's are going to cross reduce. Multiply straight across. Okay, now, you know we don't like radicals in the denominator. To get rid of radicals in the denominator, in this case, when you're adding or subtracting, you have to do what's called multiply by the conjugate. The conjugate is where you just flip the sign. So we're going to multiply by the conjugate of the denominator. So that's going to be 3 minus the square root of 3. And we're going to put it over itself. So technically we're just multiplying by 1. Okay, we're going to multiply straight across. Now, to multiply the numerator, we're going to have to FOIL. So that's going to become 3 times 3 is 9, minus 3 square root of 3, minus 3 square root of 3, plus, because we have a negative square root of 3 times negative square root of 3, so that'll just become plus 3. Okay, all over. Now, if we FOIL the denominator, this is like your difference of squares. Your middle terms are going to cancel. So this is just going to end up being 9 minus 3, which is how we get rid of the radical in the denominator. Okay, so let's just clean this up. In our numerator, we can combine our like terms. So 9 plus 3 is 12. And then if we combine our like terms here, we're going to get negative 6 square root of 3 all over 9 minus 3, which is 6. Then we can just divide each term by 6, and you end up with 2 minus square root of 3. So I know it seems like a lot of work, but it actually does simplify it down quite a bit. But that's called multiplying by the conjugate. And again, it's just a way to get rid of radicals in the denominator whenever you have a sum or a difference. Okay, let's look at a couple examples where the angles are in radians. Okay, now in radians, sometimes it can be a little bit more difficult to figure out a sum or difference of the two angles. Like for instance, in example C, we want to find cosine of 19 pi over 12. So what I would do if I were you is just think of a combination that adds to 19. So for instance, what about 15 plus 4? So 15 pi over 12 plus 4 pi over 12. And then just reduce your fractions. And, again, you're looking for angles that are on the unit circle. So let's say you reduce your fractions and it doesn't represent an angle on the unit circle. You probably want to try something different. Okay? All right, so this is the same as cosine of, if we reduce our fractions, we're going to end up with 5 pi over 4 plus pi over 3. Okay, and those are both on our unit circle. So then we're going to find our addition formula. Okay, so again, we're going to use cosine of A plus cosine of B. And we're just going to plug in our angles. Okay, so this is going to equal cosine of 5 pi over 4 times cosine of pi over 3 minus sine of 5 pi over 4 times sine of pi over 3. All right, and then you're just going to use your unit circle to evaluate the trig functions. So cosine of 5 pi over 4 is negative square root of 2 over 2 times cosine of pi over 3, which is 1/2, minus sine of pi over 4, which again is negative square root of 2 over 2, times sine of pi over 3, which is square root of 3 over 2. All right, then we're just going to multiply our fractions. So we'll get negative square root of 2 over 4. We're subtracting a negative, so that'll become adding a positive. Square root of 2 times square root of 3 is square root of 6 over 4. We have a common denominator, so we add our numerator, square root of 6 minus square root of 2 all over 4. Okay, so that is the exact value of cosine of 19 pi over 12. Okay, for our last example, we have sine of negative pi over 12. Okay, so again, think about a sum or difference. How can we get to negative pi over 12? Well, what jumped out at me is that we could use sine of 3 pi over 12 minus 4 pi over 12. So that way, when we subtract, we're going to get negative 1 pi over 12. All right, so then let's reduce our fractions. This will be the same as sine of pi over 4 minus pi over 3. Okay, so then you find your formula. So we're going to use sine of A minus B. Okay, and then you plug into the formula. All right, so when we plug into the formula, we're going to get sine of pi over 4 times cosine of pi over 3 minus cosine of pi over 4 times sine of pi over 3. All right, then we're going to go to our unit circle and evaluate these. So we get square root of 2 over 2 times 1/2 minus square root of 2 over 2 times square root of 3 over 2. Multiply straight across. And then you have a common denominator, so we're just going to add our numerator and put it over our common denominator. And that would be the exact value of sine of negative pi over 12. Okay, so we'll definitely practice this some more in class tomorrow, but At this point, I want you to practice evaluating these trig functions without looking at your unit circle, okay? Because this is when you need to try to take away the paper, okay? You need to be able to do it from memory. All right, thank you for watching. I will see you tomorrow.